We're covering 7-4, which is properties of log functions. So we're going to use the properties to simplify log expressions and translate between logs and in any base. So we've looked at log base 10 last time, how it's the default log base. You have a button on your calculator that calculates in base 10. So what do you do if you have a different base? We're going to figure that out today. All right, so remember, well, I don't know if you remember this. This is actually a property. So log, oh, we do remember this. This is for exponents. So if you have the same base multiplied with different exponents, you just add those exponents together. So for logs, it's kind of the same thing. Log to the m times n can get translated into log to the m plus log to the n. And obviously the base has to stay the same. And they use this little kind of mnemonic to help you. I think it's written poorly. It should be more like log to the j plus log to the a plus log to the m equals log to the jam. Here it looks like it's the base when I think it's not supposed to be the base. These are supposed to be the same base, whatever they are. And these are the parameters to the log function. So log of j plus log of a plus log of m is equal to log jam. Pretty clever, huh? All right, let's look at some sample problems. Express log 6, log to the base 6 of 4 plus log to the base 6 of 9 as a single logarithm. So we know that the log of one plus the log of the other is equal to the log of those two parameters multiplied. So this is going to be log to the base 6 of 4 times 9, which is log to the base 6 of 36. And remember, 10 squared equals 100, log to the base 10 of 100 equals 2. So we're saying 6 to what power is equal to 36. You can write the log function that way, and hopefully you know the answer to that would be 2. All right, second one, log to the base 1/3 of 27 plus log to the base 1/3 of 1/9. So we're going to simplify these by combining them into this. 27 times 1/9 is going to be 3. And again, this is 1/3 to some power is 3. And what power would that be? Well, we basically, 3 is a reciprocal of 1/3 or vice versa. So it's going to be -1. It's going to be your answer. All right, this would be one for you to try. All right, again, in terms of exponents, b to the m divided by b to the n is the same as b to the m minus n. We have a similar property for logarithms. So the log, of course, again, to the same base of m divided by n is equal to the log of m minus the log of n. And as I said, just as we can't combine these with different bases, we have to have the same base each time to simplify things. If they're different bases, these rules don't apply. All right, first problem, express log to the base 5 of 100 minus log to the base 5 of 4 is a single logarithm. Simplify if possible. So we're going to rewrite this as 100 divided by 4. And again, so this tells us, so 10 squared equals 100 means log to the base 10 of 100 equals 2. So 5 to what power is 25? Hopefully you know the answer is 2. Second example, log to the base 7 49 minus log to the base 7 of 7. So we're going to divide. We get log to the base 7 of 7. 7 to what power is 7? 1. Okay, do I have one here for you to do? Maybe, I guess I don't, or that one was for you to do. So I guess you got lucky. All right, next property. For any real number, p, positive numbers a and b. So the logarithm of a power is the product of the exponent and the logarithm of the base. So here we have log to base b of a to the p is the same as p times the log to the base b of a. So they have it here. Log of 10 to the third power is the same as 3 times the log of 10. Express as a product, simplify as possible. All right, so again, here's our exponent. So we turn this into 6 times log to the base 2 of 32. And here's our exponent here. So notice those go out in front. And now 10 squared is 100. Log to the base 10 of 100 is 2. So we want to know what power of 2 is equal to 35 or 32. Sorry, Freudian slip there. And we have to multiply 2 5 times to get to 32. So it's going to be 6 times 5 because 5 is what x would be here. And so the answer would be 30. Here, we want to know, this is a little more confusing, x to what power is equal to 4. And you kind of have to think a little more creatively. If we double 8, so 8, if we double 8, or square 8, and take the cube root, you're going to get 4. So that's where, whoops, let me get rid of this. That's where the 2/3 comes from. And if you couldn't figure that out, I don't blame you, but I think they just want to show you all different kinds of examples. So a to the 2/3 power is 4, it turns out. We're going to multiply that by 20 and get 40/3, which is, I don't know, 36, a 13 and a third. I wouldn't worry as much about this one. That would be more of a challenge type problem. All right, these are for you to figure out. So express as a product and simplify. Now we're going to get to, I think it is is it our last property? No, it's not our last property. So log to the base b of b to the x is just x, and that makes sense. So 10 squared equals 100. So if we have the log of 10 squared, which is 100, it's going to be 2. And then this one is a little less obvious, I think. Well, no, I guess it's not as obvious. This example, I think, is less obvious. It's b to the log b of x is equal to x. So this says, whoops, the example they give you is 10 log, whoops, that's not it either. 10 to the log to the base 10 of 2 is equal to 2. So if we think about that, so this problem, log to the base 10 of 2, is saying 10 to what power is equal to 2, and you're raising 10 to that power. So it's kind of like multiplying by the reciprocal in a way. And if that's not very clear, and I can understand why you just want to remember the rule. So if you have the base is same as this, then whatever you have as the parameter to that log function is going to be your answer. Whoops. So let me go over these. So log 3 to the, so this is the first property, log to the base 3 of 3 to the 11th. So 3, you can think of it as, well, the property tells us it's going to be 11. And if you think about it, if we say, we rewrite this as a product, 11 log 3 to the third, what power of 3 is 3? It's 1, so it's going to be 11 times 1, or 11. So that's mathematically why it works out that way, but we're given this as a property. Here we have log to the base 3 of 81. they rewrite 81 as 3 to the fourth, and so that means it's going to log to the base 3 of 3 to the fourth is just going to be 4. This tells us that if we have this and log to that base with this parameter, the answer is just going to be that parameter, which is 10. Right, a couple for you to do. Bring questions if you have them. And our last one is very useful. Our last example or property, sorry, is a formula, change of base formula. So we have the log to the base 10 on our calculator. We don't have log to the base 5. What if we're given a problem in log to the base 5, that like log to the base 5 of 6.5? That's not something that we can kind of do mentally with using powers. But we can actually change it into form. We can put it on our calculators. So this is the rule. Log to the base b of x is equal to log to the base a over x over log to the base a over b. So we typically use this to do logs with different bases in our calculator. Here's the example they have. Log to the base 4 of 8, if we want to change that to base 2, it's going to be log to the base 2 of 8 over log to the base 2 of 4, which was our original base. If we have log to the base 5 of 20 and we want to put in our calculators, we're going to say log to the base 10, which is the default of 20, over log to the base 10 of 5. So in our calculator we would just put log of 20 over log of 5. And that's why this is very useful. Okay, evaluate log to the base 32 of 8. So if I'm going to change the base, I would put in log to the base 8 over log to the base 32. Since there's no base, it's base 10, put it into my calculator, and you would get the answer. You can also figure, this one you could actually figure out without a calculator, because we want to know 32 to what power is equal to 8. Oh, and actually, they changed the to base 2 because, and then they can figure it out. So they're going to calculate it based on log to the base 2 of 8 over log to the base 2 of 32, and we know 2 to the third power is 8. So this is going to be 3 to the fifth power. So you could do it without a calculator using the powers that way, or you can just use your calculator. Either way works. But in both cases you did have to change the base. All right, these are two for you to evaluate. Either way you would like to is fine. And then logs, one of the ways logs are used is in Richter scales. So we're going to go over an example. Richter scales are used, or they're used in loudness, decibels, and Richter scales, which are the magnitudes of earthquakes. These are all energy types of values, so logs are used in energy types of problems. So the Richter scale is log. An increase of 1 corresponds to a release of 10 times as much. Because remember, the log value is the exponent. So that means if it's 2, it's 100. Basically, the value is 100, not 2. So it's not a doubling, it's 100 times more. All right, so let's look at a practical problem. Tsunami that devastated parts of Asia in December 2004. Some of you hopefully remember that. Was spawned by an earthquake with a magnitude 9.3. And if you don't know, this is a very large value. How many times as much energy did this earthquake release compared to the 6.9 magnitude earthquake that struck San Francisco in 1989? Probably you don't remember that because you probably weren't born yet, hopefully, else you wouldn't be in my class. But that one caused the collapse of the bridge in Oakland, in the Bay Area, and it did cause a lot of damage. So let's look at the difference between the two. To do that, we need to look at how the magnitude relates to the energy. And here's the equation. So this is the magnitude that they give us here. Here's the energy value. So the magnitude is equal to 2/3 times the log of the energy divided by 11.8. So we want to figure out the energy for this earthquake and compare it to the energy of this earthquake. So we're going to use this formula. The energy for the tsunami earthquake, or the magnitude, and then we're going to work backwards to solve for E. All right, so first thing, we're going to get rid of the 2/3 by using the reciprocal, multiplying both by 3/2. That gives us this. And then remember, 2 logs that are divided can be written as 2 logs subtracted. So now we can put this into our calculator, figure it out, and add actually both values to the value to both sides. So the log of 10 to the 11.8, well, of course it is 11.8, we know that. Add 11.8 to both sides and we get to this. So how do we find the log of E? Well, remember, so 10 squared equals 100. The log to the base 10 of 100 is equal to 2. So if we look at this equation, what is this telling us here? This is saying that 10, whoops, I just got rid of my equation. 10 squared equals 100, log to the base 10 of 100 equals 2. So what we have is this, and this says that 10, did it again, 10 to this power, to the 25.75 power, is equal to E. So I use this equation to work backwards. And here I've rewritten it. Now I just put 10 to the 25.75 power into my calculator. And it's a very large energy number, 5.6 times 10 to the 25th. All right, now we're going to do the same thing for the San Francisco earthquake. It was 6.9. Multiplied by the reciprocal, then we change this into a subtraction. This is going to be 11.8, subtract, so then we're going to add 11.8 to both sides and get this. We're going to end up with 10 to the 22.15, and that somehow this should be up here. So 22.15 is log of E, which we then rewrite as 10 to the 22.15 power. And you can see this is 10 to the 22nd power. If we did this division, 4,000 times as much energy in that tsunami earthquake, which is a large number, which is why it caused so much damage. So I think this was an interesting example on how to use logs and how to solve problems with logs. And I'd like you to try one. Whoops, I guess not. I guess you're not trying one. You'll try one for homework. So here is your homework. Bring questions to class.